Okay, so continuing from sample space events and Kolmogorov's axioms, that video, we have 3.7, which was the last proposition, which is inclusion-exclusion for three events, which is probability E of A union B union C is a probability of A plus probability of B plus probability of C minus probability of A and B minus probability of A and C minus probability of B and C plus the probability of A and B and C. I'm just going to use this P sign to denote probability. In the notes it's something like this, but just for the sake of just being a bit more clearer and neatness, I'll just use just P for now. So how do we prove this? Again, this should be in your lecture notes. It's not in the lecture notes online, so just in case it isn't in your notes so you can't find it, I'm just going to prove it here. And why not, it's fun proving things. So proof. Well, in order to prove this, there's two things that we need to use. First of all, it's the inclusion-exclusion for two events, so 3.6, and one of De Morgan's laws, which you should recall from mathematical structures, but I'll state that later in the video anyway. Okay, so if I'm going to use inclusion-exclusion for two events, I'm going to have the probability of A or B or C, or I should say union B, union C. I'm going to need this. Let me just zoom in a bit. I'm going to need this to just be two events. So we're going to let E equal B union C. So now this is going to be the probability of A union E. Now, using inclusion-exclusion, this is going to be equal to the probability of A plus the probability of E minus the probability of A intersection E. Okay, so now we just need to sort out these E's, because obviously this is disguised as B union C here. So worry about this one first. So obviously this is the same as B union C. Well, again, applying inclusion-exclusion for two events, I can write this, particularly B union C, as a probability of B plus a probability of C minus B intersection C. So it's just this again, but instead of A union B, I've got B union C. And that's what I'm going to substitute probability of E with. So we're going to still have probability of A, that's going to remain the same, just from directly from above. And then this, well, this is going to be the same as the probability of B plus the probability of C minus the probability of B intersection C. And then we just have, along with that, minus the probability of A intersection E. Hopefully that's a bit clear. This is A intersection E. Just try to squeeze this on the end. I probably should have written it on the line below. Okay, so now we have this A intersection E to worry about, because everything here is in terms of A, B, and C. Now we've just got this A intersection E. We should note from De Morgan's laws that for any three events, don't forget E is B or C, so we can write this as A intersection B union C. One of De Morgan's laws states that we can write A intersection B as A intersection B union A intersection C, if that makes sense. So now that we know this, and obviously this is our E here, we can write this A and E as A intersection B union C, which we can write that as A intersection B union A intersection C. So obviously all of this stays the same, so we'll just bring this down. So that's going to be the probability of A plus the probability of B plus the probability of C minus the probability of B intersection C. Now we have minus, I'll just write this just below just in case I can't fit it, minus A intersection B union A intersection C. Okay, now we can apply inclusion-exclusion here, because you see if you just let A and B, well, it should be clear anyway, but if it's not clear, if you let A and B equal F, for example, and A intersection C equal G, you'll see that it's just I can apply inclusion-exclusion just as probability of F plus probability of G minus F intersection G. But I'm not going to use F and G because I think it's pretty clear from here anyway. So we can write this with inclusion-exclusion. So again, we'll have all the same with the probability of A plus the probability of B plus the probability of C minus probability of B intersection C minus, and I'll put a bracket here because obviously the minus is here, bracket. So now this with applied with inclusion-exclusion for two events, that's going to be the probability of A and B plus the probability of A and C, and then we're going to have minus the probability of A intersection B intersection C. So hopefully this is clear. If it's not, then just have this as F and this as G. Do the same thing that I did with your F and G's, and then substitute your F and G's for A intersection B and A intersection C, and you'll see you'll get to this anyway. Okay, so now we just need to expand the bracket by a minus. So this is going to be a minus, this is going to be a minus, and this is going to become a plus. And so we end up with the probability of A plus the probability of B plus probability of C minus probability of B intersection C. Then we're going to have minus probability of A intersection B. So obviously that's a minus. We're going to have minus probability of A intersection C. So obviously this is in the brackets. That's minus probability of, let's see, A intersection C. Oh, whoopsie. And then we're going to have, that's going to be a minus, and a minus makes a plus. So plus the probability of A intersection B intersection C. And so it's now been proven. So obviously, feel free to comment on how I should improve the videos and stuff like that. Obviously, I'm still starting off. But obviously, any feedback to improve the quality of the video is appreciated. I'm trying to make the best quality videos as possible. And hopefully I just keep getting better with each video. But obviously, if there's anything particularly, or if I've made a mistake mathematically as well, please do let me know. It's very, very helpful and very much appreciated. Okay, and with that, I think what we'll do next video is perhaps do some more examples of this, where you actually might have to apply the other propositions and corollaries, or perhaps this one again in a different manner, and then we'll move on to sampling, which is quite a big chapter and quite a difficult one.